we would do the next phase of the study in the neurosurgical ward. A lot of the testing are done by third parties because either we don't have the capability. Like, for example, a lot of the virus study are done in either the government lab, okay, or in Zhongnansha's lab in Guangzhou, okay. Zhongnansha's lab is doing all these RNA virus, like H1N1 human swine flu virus, H3N2 human respiratory virus, okay, and then EB71, which is your Saochok okay. And then recently we are starting to look at DNA virus, like herpes simplex virus, HPV virus, and also like adenovirus. Because the DNA virus is different from RNA, okay, it tends to infect your body, it stay in your body, it may be off, but it can turn itself on from time to time. So herpes virus, sometimes you get sangse, okay, from time to time, okay. And the problem with the DNA virus is it can also cause cancer, okay, and that is a very important part of the study that we are starting right now. In the TMH hospital, we have done it in an unoccupied ward. All the study in the hospital is always supervised by a doctor and a nurse, okay? So they basically look at our results, they look at our procedure throughout the study. So in this case, we basically demonstrated that the coating, okay, can last for 56 days. We did it for 56 days because they need to take back the word, okay? They need to use it. So that is the length of time that they allow us for testing. In PMH hospital, we did it for MDRO, like the multi-drug resistant Pseudomonas, imipinin-resistant Acinetobacter, the same bacteria that harbor the superbug, okay? So that is done in the PMH hospital, again under Dr. Bascolam and also their nurses, okay? So we did a long-term study which shown that the coating is very effective for both type of virus, gram-positive and gram-negative, for those viruses that are actually drug-resistant, okay? In clinical testing in QEH, we have done it, okay? These experiments are done 100% by the doctors and the nurses, okay? It's the only thing that we did, we coated for them, okay? So they did the study, they did all the analysis, they took 400 samples over a 1-month period and analyzed for 1,200, okay, analysis. So they shown that there's a significant drop, okay, in the number of the bacteria present in the ICU with the coating materials. And then at the same time, on the uncoated surfaces, they found MDRO, okay? So that's why they were very positive about this coating system. Now, we are working with company now to try to apply this material in some more high-value products. Like, for example, maybe non-woven materials like filter, like gowns and other material like personal hygiene materials, or even in medical packaging, especially in hospital after their sterilization, how do they maintain that the material are sterile? So these are some of the issues that we are now pursuing. Now, the other project that we had done is about painless injection. Now, this is a very good story because actually the whole project was initiated by undergraduate student, mainly because one of the students hated getting injection. Okay, so they said, okay, can we at least work on something that close to my heart? I don't like to get any injections. So in this case, like we said, okay, we'll try to make a painless injection system using a transdermal microneedle, which is safe and painless and can do controlled drug delivery. It's It's a perfect technique for vaccination or hormone therapy or even topical analgesic, and some people say even for cosmetic applications. Okay, and so the first study, this is a microneedle that we made. Okay, and we do have the sample here. So the microneedle are actually made out of a material that have very small holes in it that allows the drugs to come out in a measured manner. Okay, so this material is actually like glass. It's a glass material. Okay, which can actually very sharp. It can penetrate the skin and remain intact. Okay, now. We use glass because it's inert. That's not number one why we did it. Okay, they even come up with a prototype design for a bollocks. Okay, so that you do an injection, very rapid injection, and then you can throw away the microneedles. Okay, and then inject the next one, inject the next one. So this is, they come up with the whole prototype design, and then we are able to demonstrate that they can do the injection across the skin. Now, because of their work, it actually allow us, okay, to then go back to ITC and apply for another grant. And in this case, we found a partner from Chinese U and also from Hong Kong Poly U. And in the Poly U case, it's very interesting because his son, okay, had a surgery which removed the pancreas. So he had to get insulin injection every time. So he was he had a emotional, okay, attachment to this type of research. So we worked together. In this case, we wanted to create two types. It's a patch, okay. The one that I'm circulating right now is one of the prototype. So it will allow the quick injection of the insulin, followed by a control, okay, insulin level to maintain the insulin level in the blood. Okay. In this case, we use a microneedle. The tip is enclosed. The previous one is open for quick injection. This one for controlled one. So it can then attach to the skin surface. It can be retained on the surface. And then at the same time, we use a smart polymer. The smart polymer is that if you look at the chamber, it had a small chamber. The chamber is open, and there's a small amount of water that will go into the polymer, and that will trigger the polymer to swell in a very linear way that will then push the insulin through the microneedle into the skin. And then we can actually design a linear release for 8 hours applications. Okay, there are many other potential applications for these materials. Okay, like for example, when I talk with people in France, they are interested for military application, because like in military, if you go to war, you have to take a lot of vaccination, and the soldier hated it. So he said, you can make a patch with the microneedle with several type of vaccine all together, and then you just give it to the soldier, and then they just apply it themselves, and then push, and then do their own vaccination. Okay, because it's painless. The number of people that will basically follow the instruction is much higher, and at the same time, you don't need any medical stuff for doing that. Okay, so we did all the testing, safety testing and mechanical testing. Mechanical testing is that after it's penetrate the skin, we check whether the needle will be broken or not. Because if it is broken, maybe it will get retained in the skin. So we can show that it's not broken. And this is one we fracture it so that we can measure the strength. So we have a safety factor of around 8, okay, for these materials. Now, harmless for cell, okay, very strong for insertion. And now we are doing, working with Chinese youth to do the animal testing. So you can see the rat is very scared about his tail, not because of the microneedle, because it's painless. Because once we start the microneedle for the injection of the insulin, we have to cut the tail to measure the blood sugar level. Okay, so that's why he's scared about his tail. Okay. So the other area of the smart material that I would share with you is basically on environment, and we will discuss about clean water, and then the other one is resource recovery. Okay, I did a lot of study on indoor air purification because my research area is very close to that field, but. In 1999, a French company, Veolia, which are working on water, they actually looked me up, and basically then they came and asked me whether I would be interested to work with them on water research. So I said, okay, I would be very interested. Okay, so we start on this journey since 1999 until now, and they are still continuing it. Now, back almost like 10 years ago, okay, they already knew there's a problem with the water that you're drinking today, okay? And they knew it internally. A lot of the water, they start to observe that a lot of the water, even the drinking water, tap water, contains some chemicals, okay? And some of these chemicals are chemicals that you take in every day, okay? This is coming from your personal care products, okay? It comes from your pharmaceuticals, okay? It comes from your cleaning agent, cleansers, okay? Because all of this go down the sink and then go back into the water source, and then you pull out the water again from the water source. And then the problem is all the water treatment technology at this point cannot treat those chemicals. And there is about 20,000 chemicals that you are using every day. Okay, there are so many. It's so pervasive. Okay, and then some of these chemicals are endocrine disrupting chemicals. So they play havoc with the hormone, and then the amount that needed to cause this effect is very, very tiny amount. Okay, like in this study, we selected a few wherein they have actually found it in real tap water. One is diclofenac. Diclofenac is used, like for example, if you get sick, okay, and then hao long tong, okay, you take the diclofenac, okay. Carbamazepine is for behavioral, okay, adjustment, okay, for it's very popular in Europe. I don't know about Hong Kong. Caffeine actually they found caffeine in drinking water. Okay, it's good. So you would say doesn't matter, caffeine. We drink coffee every day, but not babies, correct? Because if it is so pervasive, it's in the tap water. Even the babies are taking it. Okay, so that become an issue. Paptalak, okay, like paptalak, like before that. In Taiwan, the paptalak level in people are quite high, and they always say, okay, that is reasonable because it's highly industrialized, and then the water contain paptalak. Until the scandal about the Taiwan pearl tea scandal, correct? Chanchi Nai Cha, okay, that is a paptalak, okay? And paptalak is used in everything, in all cosmetic, in plastics, and everything, okay? So that has become a very important problem. And our endocrine system, okay, I'm not an expert, okay? So they include glands and hormones that basically regulate them. And then most of these chemicals can actually interfere in one or more way, okay? And then, like, for example, in China, they're starting a big study on the effect of paptalak on depression, okay? Because they were very concerned of the increase in the suicide number in China, and then they were thinking whether it's related to some of the chemicals that people are being exposed to. Okay, in endocrine disrupting chemicals, they are found in domestic and sewage waste, industrial waste, and everything. Okay, everywhere they are becoming more and more. Even though the amount is small, okay, but the effect is already being seen in wildlife. Okay, even though in human. It's not yet confirmed, but it is. People have been suspecting, like for example, the sex ratio changes around the world is related to this exposure to some of these chemicals. Changes in gender, obesity, some of these are actually related to some of the chemicals. Okay, but the presence in the environment is growing. So, and one thing is like most of the water treatment, including water treatment in Hong Kong, cannot solve this problem. That is a well-known fact, okay? And then they are seeing this type of concentration, okay, present in the either in the water or the wastewater treatment plant, okay, around the world. Not only, there's no report in Hong Kong, but in neighboring countries like Korea, Japan, and Taiwan, which share the same, okay, lifestyle, at the same time are using the same staple of products, okay? They are seeing them in their water system, okay?